Wow. Welcome everybody to the Daily Space Weather. Talk about a lot of activity occurring. Radio flux back up to a level we haven't seen since December of 2020. Another stealth coronal mass ejection. Did you see our video yesterday about stealth coronal mass ejections? Coronal holes and 4 large sunspot groups. That and lots more on today's space weather video. Let's take a look at Lagrange point 5 and Lagrange point 1, where stereo A and the Soho-Lascaux C2 are located. Again, Lagrange point 1 out here, Lagrange point 5 out here. And we've got missing data on the one coronagraph, so let's pause that. The other one, we see another minor, stealthy, Earth-directed coronal mass ejection. So once again, data not showing up here on stereo A. We're just waiting for some data to come in from that. But the Soho-Lascaux showing some additional ejecta. So 2 stealth coronal mass ejections forecasted there in the past couple of days. That's why we've had the words coronal mass ejection warning on our videos for a few days. Congratulations on finding our channel, by the way. Here's the colorized magnetogram. This sunspot here looks like it's just itching to do a flare, and in fact, there's a solar flare happening while we're recording the video today. Let's continue on with some more spectacular imagery here. More composites. This is 1700 and 171 angstroms. That data from the SDO, the Solar Dynamics Observatory. Not half bad. All right, and let's continue on here with more composites. Here's 304 and 335 in the Northern Hemisphere. And we'll show you some more footage toward the end of this filament release. There's a filament release right here, which you may be able to see in these wavelengths. We'll also show you the Southern Hemisphere in these wavelengths. Our custom views. And pretty sure you're not going to find imagery like this anyplace else on the internet, especially not forecasts of solar activity. And again, thanks for tuning in. Congratulations on realizing our channel exists. It's just spectacular imagery. And we've got more to talk about when it comes to coronal holes. I've got some important heliophysics to share with you toward the end of the video. First, a bunch more data. First, and before that, a little bit of information about the 10.7 centimeter radio flux. So the 10.7 centimeter radio flux was discovered in 1947 by some Canadian radio operators who noticed that there is a correlation between a certain frequency, 10.7 centimeters, which is also 2800 hertz, megahertz rather. So 2800 megahertz, 10.7 centimeter radio flux, whatever you want to call it, is a signal that is proportional to sunspot number. So it is one of the more important data points as far as solar activity. And this was, again, just recently discovered in 1947. Not a particularly old aspect of following solar activity, as sunspot number is the primary other thing. So the radio flux now up to 100. So this is a level that we haven't seen here since December of 2020. So a big uptick in solar activity here. Although no solar storms currently forecasted. So NOAA not forecasting any solar storms. Let's see if they even see these stealth coronal mass ejections that we saw. We did a video about it yesterday. So perhaps check that out. And it doesn't look like they have anything modeled there. So there are actually 2 CMEs headed Earth's way, folks. I mean, I don't know what else to tell you besides they're not diffuse or expected to cause very much of a blip. They'll barely be detectable. But those are the hardest ones to forecast and detect. So that's why we do it, not because it's easy, but because it's hard. Anyway, no storms forecasted, and I would agree here. I don't expect to see a big uptick in solar anything. Check out how low the solar wind speed is, too, 286 kilometers per second. And let's briefly look at seismicity. As we saw a weird earthquake here, there's the 90-day bar graph, the last 90 days of earthquake activity, courtesy volcanodiscovery.com. And check out this quake. It was so close to the North Pole, it's basically at the North Geographic Pole. It's shown as north of Svalbard. It was a 5.1, a significant magnitude quake there. So close to the geographic North Pole that it's not appearing properly on the map. There's where it is on the USGS map, and you can see it doesn't really show up right. Let's check the rest of the list here. Briefly taking a look at seismicity. So Taiwan also saw a 5.2. No quakes over a 5 magnitude here. Everything is lower than a 6, I'll say. Sandwich Islands, South Sandwich Islands region saw a 5.0 once again. Colombia saw a deep quake. Fiji saw a deep quake. That 572-kilometer deep quake was a 4.9. It would have been like a 6 plus had it been at the surface. Let's look at volcanoes briefly as well. Karimsky, volcanic ash not identifiable in satellite imagery. Don't assume it's not erupting. There's probably nobody there on the Kamchatka Peninsula. Where Shiveluch has significantly decreased its activity. Subanosejima in the Ryukyu Islands, 6,000-foot ash plume produced from it. Mount Ibu exploding, flight level 070, 7,000-foot ash plume. White Island, north of the North Island of New Zealand, north of the North Island, exhibiting a constant glow and deformation, showing some subsidence around the active vents. So we may be seeing like a collapse, a caldera collapse sort of a thing about to happen there at White Island. Aviation code remains at yellow. Samisa Pochnoi in the Aleutian Islands, exploding, flight level 150, 15,000-foot ash plume there. Popocatépetl in central Mexico, exploding, 20,000-foot ash plume from Popocatépetl. Fuego in Guatemala, exploding, 15,000-foot ash plume from Fuego. Revenador exploding, 15,000-foot ash plume over Ecuador. And Sabancaya, not identifiable in satellite data. Let's assume it's erupting. Shout out to Brett, who has Sabancaya on his bucket list. Here's the magnetometer over the past 3 days. Earth is in a North Pole-oriented current sheet. Nothing to write home about here. Those measurements are from the GOES 16 and 17. Here's the current sheet. And you'll see Earth snap across into a North Pole current sheet, shown there in green. There's the last image, and we can expect to stay in a North Pole current sheet for the extended near future. Again, green is north, red is south. Pardon my bad-looking arrows. And by the way, this data gives us great insight into some forecasting aspects of solar activity. Here is the line of sight plot. It's basically the same data, but from the line of sight perspective, it also includes a solar magnetogram. Basically a 3D view of the current sheet. Here's the sun's B field shown in blue. It's the line of sight coronal hole plot, and you can see a large North Pole-oriented trans-equatorial coronal hole rotating into the Earth-facing zone here. It's not very wide, though. It's just a narrow coronal hole here. We'll see if that remains intact. The South Pole-oriented coronal hole also growing here. And again, I think there is a relationship between coronal holes and sunspots. I'll talk about it briefly at the end of the video. Don't miss that. It'll be accompanied by additional spectacular solar imagery. Almost like this. This is the northern sunspot. That's this area right here. The rest of it is just a plage. It's in ionized iron there, by the way, 171 angstroms from the SDO. And I got to say, the SDO is one spectacular piece of equipment. Possibly my favorite ever. Parker Solar Probe is pretty good too, but anyway. Here's one of the southern sunspots. Here's some more, the other two of the southern sunspots, and these are the ones to watch. These things are beta gamma class, and they are capable of producing very large flares, M and probably X class. especially considering their proximity. You can see they're even interacting with each other a little bit here. Those are two separate sunspot groups, folks. Lots of ombre. And by the way, if you want to look up all this stuff yourself, head to the Integrated Space Weather Analysis Center. It's got probably more stuff than you could ever possibly want to analyze space weather. So yeah, sunspot 28, 63, 64, 65, 66, and for some reason this one doesn't have a name. I don't know what's up with that. They're showing 67 setting over here. Looking like old data. Let's see if the detected filaments shows up. Looking like old data there too. Just a moment. And we'll just truncate that. That has been dropped from the rotation. This data here is a little more current. Moving on. And there's the GOES X-ray flux. There was a C-class flare that happened while we started recording the video. So it was actually just happened to be just right around there when we started to record today's video. Shout out to the sun. Dear the sun, if you're conscious, leave us a comment in preferably on Smash Team, on one of our posts on Smash Team, but you could also do it in the YouTube comments, perhaps. No spikes in the proton flux. How about the real-time solar wind data? Pretty uneventful here. We saw a weak coronal hole wind stream. Not much else to comment on. Pretty unremarkable solar wind here. Current conditions are about 14 protons per cubic centimeter. Solar wind speed incredibly slow here, 287 kilometers per second. Very, very slow solar wind speed. And at least 2 CMEs headed Earth's way. So we may see a signal if it remains this slow. And at the request of one of our viewers, we've actually included a different geospace magnetosphere movie here. We're going to show density as well as pressure. As we saw some turbulence here in the density, let me bring this back. You'll see some changes here in the density. Some backflow from the magnetotail side, I guess you could say. The sun would be off to your left in these images, and you're looking at the equatorial plane view as if you're looking down at the pole of the planet, and the meridional plane view as if you're looking at the side of the planet. That would be on the right. And you see some plasma turbulence happening here with density changes. Here's pressure. That was protons per cubic centimeter. This is pressure in nanopascals. So we see some pressure subside there on the equatorial plane dawn side of the planet. Nothing too crazy going on. Keep in mind on this density imagery, this is showing high density in dark blue and low density in white. I'll let that play through a second time. Plasma density shown in protons per cubic centimeter. The scale, by the way, is only 0 to 4, and it is modeled by the Space Weather Modeling Framework. Also, we're going to show ground magnetic perturbations. This would be geospace delta B, changes to Earth's B field. It gives us insight into what's going on with the polar excursion. It shows us what's happening in magnetic flux density measured in nanotesla at the ground level. Again, it is modeled by the Space Weather Modeling Framework, courtesy University of Michigan. It's 4 hours of data like the last 2 frames we showed. Continuing on, global geomagnetism currently calm at a KP of 2, and that's from a bunch of ground-based magnetometer data to get these global 3-hour bars. Here's what's going on in the solar system, and welcome to another new moon. Are you a werewolf? Are you an anti-werewolf? Do you like to celebrate the new moon? Are you a person who sleeps well at nighttime and goes out in the daytime and is a nice person who's well rested and well fed on things besides human flesh? Well, congratulations. You may be a reverse werewolf. And be very careful of reverse werewolves, folks. They're very scary. I'm not sure. Depends on what religion you are, I guess. But, you know, reverse werewolves, they don't get along well with werewolves. Fortunately, they go out at the opposite times. Actually, the reverse werewolves just sleep at night. Anyway, let's advance this 1 week. Happy new moon. There's where things will be in a week on the 14th. We've also put up a star chart here to help orient our viewers. Some are more spaced out than others. If you want to know what's going on above your head, check out this is the all sky chart here at in-the-sky.org. We're not affiliated. We just like the site. Our star chart includes the ecliptic and the galactic plane, if you're wondering. Today's cosmology segment's integrated. Check our playlists for over 200 other cosmology segments that are separate videos. And we're going to actually pick a random number today. It's 286, which coincides with an object at the Neil Gehrels Swift Bat X-ray Observatory. 286, an easy number to remember. Reminds me of old IBM PC compatibles. Today's featured product Today's featured product is a Safer 2 Galaxy UGC 4730. And here are the hard X-rays from that galaxy over the past 16 years and over the past 30 days. And it looks like it probably has a bit of a cyclicity to it, as we see some dense readings and then some lulls and then some dense readings. But over the last 16 years, a consistent X-ray source. Let's see if it shows up on Simbad and the CDS portal. So there it is, a bit of a picturesque galaxy. Let's look at it on CDS. So here it is on the Coronal, which is an interesting thing. It looks like fish scales here. What are we seeing? It's the Coronal. What is that, the monkey? I have no idea. I don't know my astrological signs, and I don't plan to start. Let's look at it in some other surveys. So it does show up as an X-ray source here. Here's a false color image. There it is in X-ray. How about an optical from the Pan stars? And there's a great view of that Seifert 2 galaxy. Seifert 2 galaxy, rather. And perhaps the features of this are a little bit obscured. There is some tiny evidence that there may be some sort of a spiral pattern here. I see a little bit of curved optical light there. Curved optical light bands, I should say. And here it is on the 2 mass. It's Galaxy UGC 4730. A Safer 2 galaxy. It's today's featured cosmology object. By the way, if you never checked out smashamash.com/forum, there's a cosmology forum there. And we've even got a forum on memes. It's completely free. You can access it if you like. smashamash.com/forum. Thanks for the comment, Robert. Some of your comments are memes in themselves. Here's another galaxy. It's the astronomy picture of the day. And it's believed to be a galactic merger, as we see 2 apparent cores here. Now this little irregularly shaped galaxy here is a little smaller than the Milky Way. It's only about 100,000 light years in diameter. Milky Way is estimated to be more like 150,000 light years in diameter. 100,000 versus 150,000 isn't that big of a size difference in the scope of galactic sizes. So what's interesting about this one is we've got 2 different apparent nuclei here, maybe even 3, as we see a very dusty region here with quite a lot of X-ray. We've got a very dusty region here, which is probably obscuring a lot of X-ray, and then another high X-ray region here that's less dusty. So that's pretty interesting there. I'm pretty sure that's a composite image. Let's see, it's the Hubble. It may just be the Hubble Space Telescope. It is just the Hubble Space Telescope. So I think that's in different wavelengths there. Anyway, that is NGC 520 from the New General Catalog, the astronomy picture of the day, apod.nasa.gov. apod.nasa.gov. And we'll do a little slow scroll over this. during our space weather intermission, whatever kind of disasters are happening outside where I'm located, we're hoping they're not too bad as we hear sirens all over the place. Let's hope it's not creeping doom. And that's today's cosmology segment, which we hope was not creeping doom. Please leave a comment if your favorite space weather videos are about creeping doom. And bridging the gap between cosmology and Earth weather are cosmic rays. We don't always go over them. Sometimes we talk about them in the cosmology segment, sometimes not. We're going to talk about them today as part of the daily space weather video. So here it is, the Opacity Neutron Monitor's past 30 days showing an uptick in cosmic ray flux. Yeah, an uptick over the past 30 days. Also at Barentsburg, an uptick over the past 30 days. Let's go farther south. How about Athens, Greece? Athens, Greece showing an uptick in the past 30 days at their neutron monitor as well. How about even farther south to Mexico City? Now, Mexico City is mostly flat over the past 30 days. Maybe a slightly downward trend. Let's check out Oulu, Finland, and some Antarctican monitors. Oulu, slight uptick over the past 30 days. DOMB Antarctica, slight uptick over the past 30 days there. And DOMC Antarctica, similarly slight uptick. So there's a cosmic ray report. We've thrown it into the daily space weather as we look at a lot of data, preferably relevant data that has something to do with something relevant. We're also seeing very high levels of electron flux, but it's not causing any charging hazards at the moment, as far as I can tell. There's your Spacecraft Environmental Anomalies Expert System. Here's a one-year chart of the relativistic electrons as reported by Solon.info. And we're going to see higher levels here. We're going to go back into warning levels once again today. There's your 3-day electron flux chart. Shout out to SMASH team who gets alerts about this. Here is the relativistic electron forecast. And I would tend to think there's going to be a similar level today, but not outside the realm of that forecast by the green boxes there. Here's a diagram of Earth's Van Allen belts. And here's the total electron content forecast. We're seeing very high levels here over, I believe, the Indian Ocean again. So over Southeast Asia, Asia in general, the Eastern Indian Ocean, also some over Western Africa, some very high levels of electron flux there. Surprisingly high levels, a bit of a disorganization going on in the belts. Next, we'll look at the ionosphere. Here's the F layer. It's located at about 300 kilometers of altitude. And here's your ionogram. And it's fairly unremarkable here. Here's the latest image from 10 o'clock Universal Time. Here's the anomaly map showing you the anomaly in megahertz from the 30-day median. Mainly high-frequency anomalies in the southern hemisphere. And you can see anomalies in the same areas we saw those high levels of electron flux. Probably no surprise to those who understand the physics. Here's the latest anomaly image there. There's 10 o'clock. Again, things looking pretty normal at 10 o'clock Universal Time. Our meteorology segments are epic. Check them out if you haven't. Here come bonus features in the form of El Teide, Spain, the ground-based observatory, showing us the latest and this filament up here has done some activity. We're going to show you some incredible imagery from SDO on that. Keep an eye on these sunspots especially. I can see stuff happening. And I think the C-class flare that occurred when we did the video came from this sunspot here. So I haven't memorized the names. If you're hung up on the names, I apologize. Anyway, there are the sunspots, and they are quite huge. So they're calling this actually two groups here. I don't know, whatever. There are a lot of umbrae. They're big. They're magnetically complex, especially these two. Those two groups right there, especially this one. You can see how symmetrical the umbrae are there. That is a strong-looking series of fields. So here's the latest refresh on the magnetogram. That sunspot is huge. That one is big, and these two are rowdy. So 4 large groups. And here's a partial filament release here. I'm not sure if this ejected or not. Part of this may have ejected. I think it was the source of a stealth coronal mass ejection. And ionized helium here, 304 angstroms on the Solar Dynamics Observatory, is great at showing filaments. Here's a close-up. If that wasn't enough for you, here's a close-up of this gigantic filament. Just spectacular. And yeah, we knew what we were getting into, folks. We started covering the sun at solar minimum on purpose. It was on purpose, folks. Last but not least, as I promised, I would briefly talk about heliophysics here. I think there's a relationship between coronal holes and sunspots. It's not a coincidence that we see them kicking up at the same time as solar cycles progress. And I think there is a chicken and an egg argument that is in the process of being won by some people who seem to understand a little bit more about the heliophysics than others. So I can't tell you much more than that, but we've brought up this view on purpose just for this comment. So this 1700 angstroms and 193 angstroms is showing us sunspots as well as coronal holes. So this area down here, that's just a coronal hole there. That's not a giant sunspot. These areas here are sunspots, a completely different sort of scenario in the chromosphere, I'll say. But yeah, talk about some spectacular imagery. Thanks for tuning into it. Congratulations on realizing our channel exists. And may that solar wind be at your back. Opinions expressed in this daily space weather video, not necessarily the opinions of Smash News Network. Least busted, name it news.